Now, what we're going to do now is we're going to simplify the numbers, okay? When you're trying to figure out whether or not something is an acid or a base, trying to look at that exponent sometimes can be a little tricky to figure out. And plus, the numbers are so small, generally speaking. There's so many zeros between the decimal point and the first number that it's not meaningful. And so what we're going to do is we're going to change it to a scale that makes a little bit more sense. And so what we're going to use is we're going to use logarithms. And I know you have logarithms in Algebra 2. And what we're doing with them is actually very different than what you did with them in Algebra 2. It's actually a lot simpler. But what you have to remember is what a log is. A logarithm is the number to which 10 must be raised, because it's base 10, in order for the number to equal the number. It's confusing. So if I said the log of 100, okay, that is, the answer to that is 2, okay, because 2 is the number to which 10 must be raised to turn into that number. That's what I'm trying to say. The log of a number is the number to which 10 must be raised in order to equal something. Okay, so it's all base 10, and all it is we're trying to figure out what that power is. Okay, so it's kind of taking those exponents. Remember I said look for the one that's closest to 0? It's kind of taking those exponents and turning them into a number that's more manageable. Okay, the way we calculate pH, and this is very different maybe from what you learned in biology, because I'm not sure they calculate pH. It is the negative log of the H3O plus for any aqueous solution. It is the negative button, not the minus button, and then there's a button on your calculator that says log. That's all it is. It's punching a bunch of numbers. So all you type in is negative, log, and then whatever the concentration is. Pretty simple. So what I want you guys to do is take out your calculators, put in negative, hit the button log, type in 1e negative 9, and your calculator should say 9. It is the number to which 10 must be raised. Now, it changes the sign, so it's a little bit different, to make this number. Okay? Go ahead and do this one. Negative log 1e negative 4, and your calculator should say 4. Perhaps you see a relationship here. And you're right. There is a relationship here, because that's where it comes from. All right? It is this number, change the sign. However, it is only that number if this multiplier in front is a 1. If it's something other than 1, it's going to be close to 8, but it's not going to be 8. It's going to be close to it. So once you type in negative log 3.5e negative 8, and let's see if we get a number that is close to 8. And you get 7.5. Okay? It should be within 1 of that 8. One way or the other. It should be within 1. So go ahead and try the next one. Should be close to 12, and I got 11.1. Okay? So when it comes to writing down pH in terms of sig figs, let's try to keep a number after the decimal point. I mean, if it's a whole number, it's a whole number. But try to keep one number after the decimal point. So this is pH. That's the one we're going to use the most. However, there is also a relationship between other things, the H3O plus and the OH minus, and we'll talk about in a minute. If the pH is greater than 7, what that means is the solution is basic. There is the concentration of hydroxide is greater than the concentration of the H3O plus. If the pH is less than 7, the solution is acidic. That means the H3O plus is greater than the concentration of the hydroxide. So it's kind of like when I was telling you guys before, just look at the number and see which one's closer to 0. It's kind of doing the same thing here. It's taking the pH and which one is furthest away from 7, whichever direction it goes, is either acidic or basic. And if the pH is 7, the H3O plus equals the hydroxide. Now, remember this? H3O plus times hydroxide is 1e negative 14. It is possible to do something called the POH, which means negative log of the hydroxide. But it's done the same way as this. It's just, that's what the little p means. It means negative log of something. So all you're going to do is type in the hydroxide and do negative log on it, and you'll find the POH. The other interesting relationship is if you took a log, negative log of both sides, well, negative log of this is 14. Negative log of this in doing properties of logs is pH plus the POH equals 14. So this is another equation we can use. So far you've got that many equations. Now, To find the H3O plus using the pH, you're going to use the inverse log on your calculator. It's a little button. It's written right above the word log. It says 10 to the x. What you're going to do is you're going to do the inverse function. So if I give you the pH and ask you to find the H3O plus, you're going to have to use this function. Okay? And the way it works is the H3O plus is 10 raised to the negative pH. Okay, you could also just do 10 raised to negative pH, and you still get the same answer. Either answer is fine. It's just less buttons to push if you use the inverse log button. All right, so let's see what you can do with this. Okay, putting it all together, all the different things. Now remember, the way this works, and I'm just going to put this on here, and it's not a bad idea for you guys. Going this direction, it's negative log of the number. Going this direction is negative log of the number. These two guys, going between them, is 1e negative 14 divided by the number. Okay, and then here, the pH is less than 7, it's acid. pH greater than 7, it's a base. Okay, so go ahead and see what you can do, and we'll talk about what to do with this one, this one, this one, and this one in a minute. So pH here is 9. This is 1e negative 5, and this is 5. This is very basic. Go ahead and go from here to here, we get 3. Going from here to here, you get 1e negative 11. This would be 11. Also basic. And again, just base it off the pH. Don't try to figure it out based on what the pOH does. You'll get yourself really confused. If the pH is greater than 7, it's a base. It's less than 7, it's an acid. Okay, let's jump down here. This one in particular I want to point out. Going from here to here, you do negative log 18.1, and you get, negative log 18.1. You get a negative pH. Okay, now you may have heard in biology that there's no such thing as a negative pH, and that is false. There are no biological systems that can handle that kind of pH. This is the strongest acid I have. It's 18 molarity sulfuric acid. This stuff is bad. It's stuff they put in car batteries to make car batteries work. Battery acid. Really bad stuff. You get this on yourself, you are going to regret it big time. Okay, it will eat through your clothes. You will get a blister. You will get a chemical burn. Bad stuff. Very low pH. Very, very acidic. Okay, going this way. The hydroxide is going to be necessarily very, very small. 5.5 e to the negative 16. And if you do negative log of that, you get a pH of, pOH of 15.3. Okay, now I want to show you how to go the other direction. Okay, the other thing, I'm going to erase at the top here. Oops, go back. The other equation that you can remember that might help you do some of these is that the pH plus the pOH will always add to 14. And you may have noticed 9 and 5, 11 and 3. This is 14. That's going to be 0. This is 4.6. This is going to be 9.4. If that's negative 0.7, this is going to be 14.7. Okay, they always add to 14. The other thing is when you're trying to go inside here, you're going to do the inverse log, 10 to the negative pOH or 10 to the negative pH. So if I type in 10 to the negative 14, I get 1e negative 14. If I do 10 to the 0, I'm going to get 1. Okay, so that's kind of a weird one, but basically it's 10 to the negative 0, which is 1. If I type in negative 10 to the negative 9.4, I get 4e negative 10. And if I do second log negative 4.6, I get 2.5 e to the negative 5. Okay, and that's how you do it. I mean, you just kind of wander through it and kind of make it work. The pH is going to be anywhere from about negative 2 up to 16. Same thing here. Negative 2 up to 16. These guys should have exponents anywhere from about 20, positive 20, to an exponent of e to the negative 16. That's about it for both of these guys. Okay, that's to give you an idea of what your answer should be. So I'm just going to go ahead and put the rest of the answers in there, and if you guys want to make sure you can do it, that would probably be a good thing. Okay, and then this is negative 0.4. negative 15. This is 10.4. This will be 3.6. 2.6 e to the negative 4. And then the last one, 3.1, 10.9, and 1.4 e to the negative 11. Okay, so basically you kind of have to get used to how your calculator works. That's really what this is all about. I have a lot of these for you guys to practice, because how calculators work, you kind of have to get in the habit of doing which buttons go where, which buttons do which, that kind of thing to make it make sense. This one is a base, this one is a base, this one's a base, base, acid, and acid. And again, all I'm doing is looking at those pHs. Less than 7's an acid, bigger than 7's a base. If it was 7, it would be neutral. Okay, now acid strength. Some acids dissociate water into their ions very easily. They're called strong acids. There is no equilibrium. It's 100% in one direction. It's virtually only products. They are considered to be strong acids. There are 6 of them. Okay, hydrochloric, hydrobromic, hydroiodic, nitric, perchloric, and sulfuric. 100% turn into H3O+. Okay, remember that's the stuff that makes them strong acids. So the H3O+ is equal to whatever I give you as the molarity of the strong acid. So calculate the H3O+ and the hydroxide of the solutions. Remember, these are all strong acids. The only thing you have to watch out for is occasionally that. So the H3O+, 0.15. H3O+, 0.0235. H3O+, 2.5. And then this one, because it's got that 2, you're going to double it. Okay, to find the hydroxide, now you're back to doing the same chart. It's 1e negative 14 divided by the number. So 1e negative 14 divided by 0.15. You get 6.7 e to the negative 14. Here, 1. 4.3 e to the negative 13. 4e negative 15, and then this last one, remember you have to double it because it's got that 2 by the hydrogen. 2e negative 12. Okay, now the pHs for these will all be acidic, but we'll calculate them. Negative log of 0.15 is 0.8, and 1.6. This one's going to be negative, because it's greater than 1. Negative 0.4. And 2.3. Okay, so strong acids, all you literally do is take this number and put it in the H3O+, and then you're off and running. Just doing whatever we've been doing all along. For bases, the same idea. Strong bases completely dissociate into OH-. And the strong bases contain hydroxide, and they tend to be either NaOH, LiOH, KOH, maybe RbOH. That's pretty much it on that side. And then you have these dibasic ones. Remember, they've got 2 hydroxides. So whatever the concentration is, it's twice the molarity for the hydroxide. So for this one, these are all strong bases, literally in the hydroxide column. 0.25, 0.0535. And this one, because it's got that 2, it's 2 times 2.5, which is 5. And same thing here, 2 times 2.5 e to the negative 3. And that's a negative in there somewhere. There we go. 5e negative 3. So you have to watch for that. Okay, other than that, it's pretty straightforward. Again, 1e negative 14 divided by the number goes here. So 1, you get 4e negative 14, and then to find the pH, it's just negative log of the hydrogen. That hasn't changed at all. 13.4, and again, you would expect all of these to be basic because they are bases. And you get 1.9 e to the negative 13, 12.7. It's going to be 2e negative 15. 14.7, and then the last one, (2e negative 12), and the pH is 11.7. Okay, so the big trick to recognize is it a strong base or a strong acid? If it's a strong base, it goes where it says hydroxide. If we were looking at the previous one, where was it? Oh, good heavens. There we go. If it's a strong acid, it goes where it says H3O+. It's just a matter of paying attention to what you're doing and putting them in the right place.